So say we have a function like r of s is equal to 3 minus 6x minus 3s squared. Now the first thing I want you to notice is that the function is called r and it's evaluated at s. So s is the dependent variable, which means the dependent variable is this s that is squared at the very end. This x in the middle, you can think of it as a constant. It's not a term that's going to be affected by the function. So if I want you to find, for example, r of negative 2, well, r of negative 2 is r of s when s is equal to negative 2. So in this case, we replace only the s with negative 2. The x stays by itself. So r of negative 2 is equal to 3 minus 6x minus 3 times negative 2 squared, right? So simplifying, this becomes 3 minus 6x minus 3 times negative 2 squared, which is 4, which is 3. So we have 3 minus 6x minus 12 negative 9 minus 6x, combining these two like terms, 3 and negative 12. So our final answer, since we can't do anything with that x, is r of negative 2 is equal to negative 9 minus 6x. So let's do another example just to make sure that we get the basic idea. So I'm going to rewrite the function since I'm going to scroll down. R of s is equal to 3 minus 6x minus 3s squared. So let's say I want you to evaluate r of 1. So r of 1 is r of s when s is equal to 1. So we're just evaluating, we're just changing the s, replacing the s with 1. In this case as well, the x we just leave alone since it's not the dependent variable. So r of 1 is equal to 3 minus 6x minus 3 times 1 squared. So simplifying, this is 3 minus 6x minus 3 times 1 squared, which is just 3 times 1, which is just 3. And then finally, you can combine 3 and negative 3 to give you 0. So what's left over is the minus 6x that we can't do anything with, right? So finally, we can write our answer as r of 1 is equal to negative 6x.